In this video, we are going to cover section 3.5, transformations of functions. We are going to graph functions using horizontal and vertical shifts, as well as reflections around the x-axis and y-axis. We're going to talk about if functions are even or odd, and we will also graph functions that have compressions and stretches. And finally, we will combine transformations. Now, we're going to talk about a ton of different kinds of functions. Most of the time I use quadratics to show transformations, but all the transformations can be applied to any of these functions, including other ones that we haven't even covered yet. Okay, let's jump right in. So for all of our functions, I'm going to go ahead and draw the parent function in yellow. So here is my quadratic function, x squared. Okay. Now, the very first transformation that we see is a +1 at the end of the function. That signifies a movement of up 1 unit, whereas in this other function we have a -1, which signifies a downward movement of 1 unit. So what that means is we are going to move down a single unit and draw our curve again. Okay, notice that that was a vertical shift. Oops, I went the other direction. Here we go. Up a unit, vertical shift. This is the one that moves down a unit, and that is a vertical shift downward. Okay, so we're going to cover vertical shifts in that first one. In our second transformation, we are going to work with horizontal shifts. Okay, as usual, I'm going to go ahead and draw my original. It looks like that. And then notice that we have a +1 that is inside these parentheses. That tells us it is a horizontal shift. It is also moving to the left. So I'm going to move left 1 unit and graph. On this other one, we have a -1, which means we're going to move to the right 1 unit, and it's going to look like that. Okay. The reason that we are moving to the right when it's minus and to the left when it's plus is because the original function would actually say x minus h squared. And so if you have a double negative, it's written as a positive. So really it is a minus, but because there's two minuses, we can write that as a positive value. My next transformation is going to be the stretch and compression. So these are vertical stretches, vertical stretch and compression. Okay. So in this one, we are multiplying our x squared by a 3, which means we are stretching and elongating by a factor of 3. Whereas with 1/3, we are widening and getting larger, but at a slower rate because it is only increasing by a 1/3 instead of by 1. Okay, so 1/3 makes the quadratic shorter and wider. 3 makes it longer and skinnier. That will hold true for any value that is greater than 1. And the second one will be any number that is between 0 and 1. Finally, we have reflections. Notice that I did choose to use a different function to represent reflections. The reason being quadratics look the same when reflected over the y-axis. So I wanted to show you what both of those could look like because I want them to look different. So here's the original square root function. Okay. In this first one, you'll notice that there is a minus outside of the root. Outside of the root means that we are reflecting over the x-axis. Okay. And then that means when there is a negative inside the root or inside parentheses or inside the absolute value bars, we are reflecting over the y-axis. Okay. And again, the reason I don't use a quadratic is because a quadratic is already symmetrical around the y-axis, so reflecting over y makes no change. Therefore, I think it's better to use a different kind of function. Okay. Now, in order to determine if a function is even or odd, we need to take a look at two things. Okay. If it is even, okay, it is symmetric around the y-axis. Okay, even functions are symmetric around the y-axis. Okay, and then if they are symmetric around the origin, that is an odd function. Okay, so for example, if we take a look at the function x cubed, okay, and we make the x values negative, okay, it does reflect, okay, over the y-axis. And if we make x and y negative, it becomes the same function. Okay. If it's reflected over both axes, the result is the original function. Okay, so that means we have an odd function for a power of 3. Okay. Keep in mind that a function can be neither even nor odd. It doesn't have to have that symmetry. And then the only one that is both even and odd is the constant function f of x equals 0. It doesn't have to be 0, it could be any constant. So any value. Okay. That's it for this section covering transformations.